So we're going to move on to the infrared temperature guns, and that's what this device is here. So I'm going to open this up. On these are what we're using to do the temperature reading on the surface. It uses reflected, emitted, and transferred energy to determine what the temperature is of that surface. So it's got a little optical device in there that kind of reads those three different things, and it calculates out what that temperature is. There is something that kind of affects that, and that's what the emissivity of the surface is. Emissivity is what it's called, I think. I don't think I know. But you have to set that on your gun. So when you first open up your gun, it's not going to have the battery in it. I've already opened this one up and put the battery in. But that's one of the things that you need to do, is you need to set that emissivity rating on the gun. We're going to go through a little bit of that. As far as these, you can't just leave them on your dashboard in the heat, in the defroster. You need to keep it either on the seat next to you, or somewhere in a console or something where it's not directly in hot sunlight, or on your dash or something like that. That the ambient temperature does affect it. So when you get out of your truck to take a temperature, you're going to just keep it with you, take it back in the truck and set it down. Don't leave it outside for a long time and then put it back in the truck, because that ambient temperature and the changes in it affect it. And then there's something else that happened this summer that you're all familiar with all of the smoke that we've had. These actually try to see the surface. So if you have a lot of particulates in the air, if you're in an area that's really dusty, construction happening with dust or whatever, if you're in an area where there's a lot of fog, heavy fog, or smoke in the air, it can affect the readings. Now in the wintertime, and what we're using these for, we're probably going to have less of that than what you would experience in the summertime, like we did with this smoke this last summer. And then you're going to want to take a couple of readings with these. Don't just do one and say, oh, it's 70 degrees, that's good, or 32 degrees. Take a couple on the different surfaces. Make sure that you get plenty of readings with them. And they can also be affected by radio frequency. So if you've got a CB radio or some other type of high-powered radio in your rig, you kind of want to get away from your truck, because it can affect it. So be careful of that. And then don't try to shoot things through the glass on your window. It doesn't work, because otherwise it just sees the glass and it takes the temperature of the glass and not necessarily the surface outside. If you have the laser on, the laser will actually point through the glass and hit the ground, but it's not really reading the ground, it's reading what the surface temperature is on the glass. So that's some of the particulars about these that you need to be careful about. A little bit more about what emissivity is it's basically the emitted heat, or emitted transfer of heat from a surface. And they use a standard black surface as the perfect emitter, and then whatever you're shooting with that gun, it's looking at that surface and taking using some math to calculate what the ratio is compared to a perfectly black surface. So that's what the emissivity is. So when you first get your gun, you actually have to set that emissivity, and when we're looking at the surfaces that we deal with, most of them are going to be asphalt or concrete. You may have some areas where you have brick pavers, and so on all of those you have some different emissivities, and we've looked those up. The best place to set your IR gun for the purposes of which we're using it for is at 0.94, and in the instruction it shows you how to do that. Each gun is a little bit different. For the ones that we're using, there's a mode button, and you can just hit the mode button until you get a little E and it has a number and it's in a decimal place. So when I do that on this, I can set that all the way to E until I get there. It says 0.94 right now because I preset it for this class. See that? So I already preset it, but if it was something else, then you could reset it. And that's something that you're going to want to do on a regular basis, is check to make sure that the emissivity setting on your gun is set to what it should be. For the surfaces that you're hitting, 0.94 is probably the best place to put the gun to get the most accurate readings. Any questions on that? Anybody not understand? Great, great. So, just to kind of recap here, remember, don't put your infrared gun on the dashboard. Keep it on the seat next to you. If you're going to be using it outside all the time, you want to put it in the toolbox in the truck, and that's fine. Just don't make sure that you don't carry it back into the truck with you. It can take up to an hour for the gun to stabilize with that big of a change in temperatures. Also, don't subject the gun to high heat. So you don't want to put it up next to the heater. You don't want to have it next to an arc welder. There's lots of things that can affect it. And then make sure that you record whatever the temperatures are. There is a function on most of the guns that are out there that allows you to have a history and then see what a minimum and a maximum are for the amount of temperature readings that you take. Some are set to only allow or calculate up to 10. Others have longer ones. The ones that we're going to be using they have a history of 10. So you can look back 10 readings ago, and it'll always calculate what your minimum and your maximum are based on those 10 readings. So that's something that might help in recording those temperatures. But it's vitally important that we make sure that we get surface temperatures on the sites, and we calculate our ice melt application based on that rather than using the ambient temperature, because it can change how much is going down. So, any questions on that? Yes.
Since we're out using these guns in various weather conditions, do we have to clear the ground to the asphalt before we get the reading? Because there's 2 or 4 inches of snow. Is it going to read the snow?
Yeah, it's going to read the snow. You're absolutely right. It is going to read the snow. So you will want to clear that out. Now we know from some of the history of just temperature readings that we've had in the past that normally snow happens at about the 28-degree mark, but that surface temperature could be something else. And so when we went through with the other training that we went through, it was, kick some of that snow out of the way. It is going to have ice on the surface, but ice can be at 20 degrees or 0 degrees or negative 20 degrees. It can also be at 28 degrees. So yeah, you do want to try and get down to the surface, because the surface is where we work, right? It's not the snow on top. Everything is at the surface. That's where the ice melt goes. That's what we're concerned about, making sure that we break that bond with the ice and the surface. So that's where you want to get to. So yeah, just kick some out of the way. Any other questions? Brian?
When you point the gun at the surface, does it matter if it points straight down, or can it be at an off angle?
You could probably be off at an off angle a little bit, but you also don't want to be too far away. You can be too far away. So 3 to 5 feet is okay. You start getting beyond 5 feet, and then you risk having too many particulates in the air for it to really get an accurate reading. So the closer the better, but you can also be too close. So if you get like right up next to the surface, that's probably not good either. So, but if you're just standing here and you just do that, that would be perfectly fine. So 3 to 5 feet.